All right, in this video, I'd like to introduce a very exciting topic. I'd like to talk about slope. Now, slope is just a number. Slope could be a number that would be negative, it could be 0, or it could be positive. It's just some number. But what's interesting about slope is that it's used to describe lines, okay? And a good way of introducing this topic is to talk about terms that might be used to describe Mount Everest here. What are some terms we might use to describe this mountain? Well, I would say overcrowded is the first term that comes to mind. I mean, I don't even know how people get up this thing right here. It's so crowded. But let's look at this region of the mountain and this region over here. Would you like to walk across either this region here or this region here? Would you like to walk across there? Probably not. I mean, there's a reason why that there's this big old line right here. So this mountain would be very steep. Okay, that's the term I'm trying to get at, steep. And the same reason we would describe this mountain as being very steep, we would also say these lines are very steep. Now I'm going to kind of foreshadow a little bit, but this would be an example of a line with positive slope, and this would be an example of a line with negative slope. Both these lines we would describe as being very steep in this context. So very steep. Steep. All right, let's look at example number 2. Let's say we were skiing down a bunny hill. Okay, let's look at this kid right here. I mean, this kid is essentially walking right now. So would this be an example of a very steep hill? No, not at all. So this would be an example of something that is not steep at all. And for that same reason, this line right here is not steep at all. So not steep. All right, now let's talk about slope more as a numerical thing. So here's some line. The slope here is a positive number. So the slope would be equal to some positive number here. And the reason it's a positive number is that if we start on the left side of our graph over here and we move our way to the right, so the person kind of walks up the line. So it starts on the left, walks up the line. The analogy used is hiking up a hill. And whenever you're hiking up a hill, you have positive slope. If you are starting, again, you always start from the left and you're going down, moving your way to the right, that would denote a negative slope. So this would be positive slope here because we're going up. Negative slope would be going down, okay? Now let's put this into context of steepness. Let's say we were asked to describe the slope here. Let's look at that line right there. Now the person's a mountain climber, right? It's a very steep line, right? It's almost vertical. So the person climbs up the mountain. That denotes a positive slope. The person's climbing up the mountain. But we also know some other things about it. When the slope is a very large number, and it's a very big positive number, like 9 trillion, you have a line that's almost vertical going upwards. It's slanted way up. It's tilted way up. So there's that example there. If your slope is a very small positive number, let's say it's 0.00005, you have a line that is almost horizontal but is ever so slightly going up, okay? So it's ever so slightly going up. Another important detail I wanted to point out, an example of a slope that is also very steep would be like a slope that is 100, okay? That would be an example of a line that is very steep. Let's describe the slope here. Recall that the slope, if this line was tilted up ever so slightly, that would be a very small positive number, right? What would be the slope here? It would be 0. The slope is 0 here. It's a horizontal line. All horizontal lines have a slope that is 0. And there is another way of thinking about it. We know that slope is equal to rise over run. In this case, delta y over delta x. delta y refers to the change in our y value, okay, between 2 points. Delta x denotes the change in our x value, the distance in our x values. So let's put two arbitrary distinct points. The word distinct in mathematics refers to not equal, okay? So we have 2 points at different locations, and let's put those on our line right here. What do we see about our delta y? Okay, we notice that that distance between going upwards between those points is what? I mean, it's shrinking down. It's nothing. So there's no delta y. Delta y is equal to 0 here. So when we substitute delta y into our numerator, we get 0 over delta x. So our slope is 0. So in the case of having a horizontal line, we have a slope that is 0. Now let's put this into context of this slope right here. Would this slope be positive or negative? The person is going down a hill. Okay, we're moving downward, and since we're moving downward, the slope is negative. So the slope would be negative here. Now, if the slope was a negative number that was like -9 quadrillion, that would mean that we would have a line that is almost straight up and down. Again, it would be almost straight up and down, but it would still be going downward, okay? So it would be going like this. If you had a slope that would be a number, let's say -0.00005, it would be a line that is ever so slightly going down, and it would still be going, it would be almost horizontal, but it would still be going down, okay? So that would be negative slope there. Lastly, describe the slope of that line right there. Now this is kind of a trick question, and since this line is a vertical line, we say that its slope is undefined. And the reason it is undefined, it's a very good reason. Let's just consider the scenario, and this happens a lot to me. Let's say you have 2 points that we have on our line, okay? So there's two points on our line, and we take those 2 points, and you have your delta x, okay? And you consider our delta x, the distance between these 2 points in the x direction, that distance is 0, right? That distance is 0. So our delta x is 0, which means our denominator is 0. So our slope is equal to delta y divided by 0, okay? So we get this situation where we're stuck with a denominator that is 0. And our slope for this situation would be delta y divided by 0. Well, this is bad. In mathematics, you cannot divide by 0. So we say this situation can never happen, okay? So we say in our definition of slope, we restrict our values for our denominator. So we say this situation never happens. This is bad. We forbid this in mathematics. So when we have a situation where we have 2 points that are going vertical like this slope, we would say it's undefined. It doesn't make sense to talk about slope for this example here, because it would lead to division of 0 for that exact reason.